Hey guys, this is Mr. Teen Tutor here, and today we're going to focus on finding the zeros of a polynomial function. This is part 1 of the video. In part 2, we will finish this problem. But in part 1, we're going to do the following things. 1. Find the number of possible positive and or negative zeros. 2. Find the possible zeros. And 3. Use synthetic division to find a zero and factor based on that. So let's focus on the first bullet point. And in order to find the number of possible positive and or negative zeros, we're going to use what's called Descartes' law. And for those of you who don't know, Descartes was a French mathematician, and he came up with this rule. And his rule was the number of possible positive zeros is equal to the number of sign variations in f of x and f of negative x. So what I just said, the key thing to take away from that is, oh, actually no, hold on, never mind, I was on the right track. Sign variations. That's the key phrase to take away from this. And I'm going to show you what I mean by that. You're going to write down the coefficients. You're going to rewrite the whole function, but include the coefficient for x cubed this time, and plus the sign. So number of sign variations. Well, we're going to see how many times the coefficients go from positive to negative or negative to positive. So from here to here, there's a sign variation. So that's one possible positive zero. Now wait a minute. Negative to positive. That's another one. And lastly, we have positive to negative. So 1, 2, 3. So there are 3, and then for the value that you get, you subtract 2 from it to find another value that could represent the number of possible positive zeros. Because there may not necessarily be 3. But now here's the deal. If you figure out that in a polynomial function that the number of sign variations, there are actually only, say, 1. Let's say there's only 1 sign variation. You're not going to subtract 2 from that because you can't have negative 1 possible positive zeros. That's insane. How can you possibly have that? So I'm going to have combinations like 3 or 1, 5 or 3, 2 or 0, etc., etc. And this also applies to finding the number of possible negative zeros as well. So, like I said, there are 3 or 1 possible positive zeros. Now to find the possible number of negative zeros, Descartes said the number of sign variations for f of negative x. So we're going to sub in negative x for here. So what do we get? We get negative 1. Again, write the coefficients because that's going to help. Minus 8x squared minus 25x minus 26. Look at this. No sign variations whatsoever, which means there are 0 possible negative zeros. Now, like I just said earlier, you're not going to subtract 2 from this number and say 0 or negative 2. That's absurd. Don't even think about doing that. That's not going to be funny to a math teacher. Trust me. Anyway, we just did bullet point 1, and this is going to help us out. Now, we're going to figure out the possible zeros. And basically what we're going to be doing now is, based on a certain concept, which I'm going to teach you in just a moment, we're going to generate a list of zeros, and only a select few of them will work, or maybe they won't, but we'll still generate a list. So in order to do part 2, we use this concept of P over Q, which basically states that you find the factors of the last term of the function, and you find the factors of the first term of the function. So the last term of the function is called P, and the last term of the function is called Q. So now, like I just said, we are going to find the factors of P and Q. So let's come over here. So factors of P. What's our value? Negative 26. Now when we list the factors, make sure you include plus or minus. That's important. So what are the factors of 26? Plus or minus 1, plus or minus 2, plus or minus 13, and plus or minus 26. Now we need to find the factors of Q. Well, Q is 1. So plus or minus 1. And then what you do is you take each of the factors in P and divide it by the factor in Q, And that's how you come up with your list of possible zeros. So we're going to take 1 over 1, 2 over 1, 13 over 1, and 26 over 1, which means that the possible zeros, like I said, not all of them are going to work. Only a select few will, or maybe it won't. So we'll see. Plus or minus 1, plus or minus 2, plus or minus 13, and plus or minus 26. So those are our possible zeros. This is important to keep in mind. Now here's the deal. We're now going to do what's called synthetic division. And this may be a bit confusing to you. I hope that you guys have already gotten a good lesson on synthetic division, but if you haven't, that's alright. I'm going to go over it right now. For those of you who have learned long division, in fact, before learning synthetic division, you should learn what long division is. So for long division, you have some polynomial here divided by some polynomial here. So for this function, if you wanted to find, or rather if you wanted to see if one of the zeros worked, or rather it was a factor, and you could factor it, then you would put something like, let's test 1 for an example. If 1 was a 0, then the factor would be x minus 1, because 1 minus 1 is 0. And then in here, the dividend, we would write this function, which is x cubed minus 8x squared plus 25x minus 26. So you would have done long division, and then you would have come up with a remainder. Now, if the remainder was 0, then obviously this is a factor of this polynomial. But we're not going to do that. What we're going to do is called now synthetic division, in which what you do is you take the coefficients of your general polynomial or dividend, and you write them in descending order. 1, negative 8, 25, and negative 26. Here's a note for you guys. Let's say the polynomial function was x cubed minus 5, let's say. And let's say I asked you to write that in synthetic division. Well, let me just tell you right now, even though this coefficient is 1, the next one's negative 5, obviously, that's wrong, because you have to go in descending order. So, because this is essentially x cubed plus 0x squared plus 0x minus 5. So you must include the zeros if necessary. So really, you would be writing it as 1, 0, 0, negative 5, and then you'd go from there. And I'm going to talk about how you do it in a bit. But the point is, when you're expressing the coefficients in here, you must include zeros when necessary if a certain power is 0. If you do not include the zeros, I'm telling you guys this right now, you are going to get it wrong. Trust me, you are going to get it wrong. So don't forget that. That is one way to screw up this problem. However, in our example problem, there are no zeros because it goes x cubed minus x squared plus 25x minus 26. So it goes in descending order, and each degree, or term I should say, has a coefficient, a non-zero coefficient. So for synthetic division, what you do is, right here, you find the zero of this and you put it here. So in this case, it's 1. And what your goal is, or actually, let me not get to that yet. I want to show you guys how this works. So I drop the first term, which is 1. And here's what I do. Listen very carefully, guys. I take this term times this term. 1 times 1 is 1. Whatever that product is, I add that to this coefficient. Add. What's negative 8 plus 1? Negative 7. I do the same thing. I take negative 7 now this time times 1, which is negative 7. And then I add negative 7 to 25. What is that? That's 18. Same thing. I take this term times that term, which is 18, and I add the result to here. And what do I get when I do that? Good job, you got it, negative 8. Now here's the deal with synthetic division. Your goal is to get this number to equal 0. If this number does not equal 0, that means that this 0 right here is not, I repeat, not a 0 of this function. So the remainder here is negative 8, which means that 1 is clearly not a 0 of this function. So you can erase these numbers, and using synthetic division, you can test all these other zeros, and we'll see which one equals 0. Or maybe they won't. That's always possible. I haven't seen that yet, but it may happen. If you have math teachers who are sneaky, they may do something like that to you. So always be aware and be very careful when you're going about solving these problems. So 1 didn't work. So let's try another number. Well, instead of putting in -1, since -1 is not a really hard number, we can quickly test -1 here. We could have done that for 1, but I wanted to show you guys how synthetic division worked in the first place. So if we sub in -1 right here, we get -1 minus 8, which is -9, -9 minus 25, which is -34 minus 26. Oh, geez. That's so incorrect. I can't even tell you how so incorrect that is. So -1 definitely doesn't work. So we know now that plus or minus 1 is not a 0 of this function. Okay, but now let's try 2. So again, drop the 1, and this time, instead of testing 2 in there, we'll put 2 here. Because the benefit of using synthetic division instead of just subbing the number here is you get to figure out how this factors. And I'm going to get to that actually at the end of this video. 1 times 2 is 2. I add it here. I get -6. -6 times 2 is -12. And like I said, well, that's a bad -12. That's a really bad -12. And I get 13. 13 times 2 is 26. Voila! This equals 0. And you know what that means, guys? Like I just said earlier, 2 is a 0 of this function. So if 2 is a 0, how would you express the factor? It would be x minus 2. Now you're probably wondering, how in the world do I express the other factor? You solved it right here. If this is x cubed, what do you think this one is the coefficient for? You guessed it, it's x squared. Because when I first multiply this binomial by this eventual trinomial, I will do x times x squared first, which is x cubed. That's the first term. By the way, this is not a plus. It may seem that way, but it's a minus. So if this is x squared, this is minus 6x plus 13. So I just figured out the factored form of this function. Now in part 2 of this video, we're going to finish this problem and find the zeros by continuing on from this point. So please watch part 2.